Hi, hello friends. Welcome to the today's session. Welcome to Unacademy. Welcome to my classes. In this class, we are going to learn the very important concept that is a transport layer. So gun-shoot question in the GATE examination. So the continuous series lectures are there on transport layer. Please don't miss any of these transport layer lectures. So let us start our session. Before starting our session, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has created a wonderful platform to serve the dedicated students. Utilize this opportunity what the Unacademy is given so that your goals are going to be cleared and your goals are going to be achieved. So dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with various papers. I taught in many premium academies with a high success rate, also had industry experience as a database side and systems side with a good relevant certifications. You also can achieve all this kind of certification just by giving your effort. And this can be solved only by an academy platform. So many of my students have completed their post-graduation from India's premium institutions like IIT and IITs, Central Universities and IIITs just by clearing a GATE examination. You also can achieve this just by taking some tips and shortcuts and guidance from the dedicated faculty members and top quality faculty members. So Unacademy has proved an interface between dedicated students and dedicated faculty members. Friends, so to crack the GATE and ESE examination, there is a need of some much more focus towards tips and shortcuts and experience by your previous alumni and experience by your faculty member. So in order to do that, there are two kinds of programs which are there in Unacademy. One is a plus, the other one iconic. So if you become a plus member, then you can able to see that unrestricted access such that live lessons like quizzes, mock sessions and mock quizzes and many kind of things which are beneficial to dedicated students. So utilize this opportunity and see that your goal is being completed because your goal is an academic goal. Dear friends, the other kind of program is iconic, which inbuilt consists of your plus program as well as consist of 1:1 personal coach. So this is a very unique program where you are going to get 1:1 personal guidance by the educator from Unacademy. So dear friends, according to plus subscription, so the current fourth year students can prefer this 12 months and the third and second year students can prefer this and first, second and third year students can prefer this super long term. So apart from the content, so by using my referral code, then I can be your guide because you're going to join under me. So use my referral code to get the admission into Unacademy. Apart from that, you're also going to get a maximized concession on the above prices. So my referral code is providing that kind concession. Please use it, this offer also. And according to iconic subscription, there are two varieties. In iconic, as I already showed you, which is a plus program is there inbuilt. Apart from that, you are going to have 1:1 guidance program. So don't miss this unique program. So there are two kinds of subscriptions, 24 months and 12 months. The current fourth year students can opt for this, and first and second, third, fourth year students can opt for this. So use my referral code. You're also going to get some concession. So once you use my referral code, then it is indicating that you're going to join under me so that I can be your guide, so I can able to give you all my guidance just because as you are part of iconic program. And friends, if you are having any doubts, please reach us just by filling this form and see that some of the courses are going on our YouTube. So this is our YouTube channel. Let's Crack GATE CSE is our YouTube channel. So dedicated faculty members are running various courses on this various subjects. So subscribe our YouTube channel and hit the bell icon for latest notifications and updates, and use my referral code so that I can be your guide. Otherwise, you will not be joined under me. So that's why use my referral code and share my experiences along with my alumni who are already done GATE program and they are working in topmost companies and topmost PSUs. This is all because of GATE examination and the completion of their post-graduation program from India's topmost institutions. So our agenda is transport layer importance in data transmission. In data transmission, multiple number of layers are being working as we are using layered architecture, that is a TCP/IP, and a reference model like open system interconnection. So in both of the model, if you observe that, so according to OSI or TCP/IP, whatever it may be, so there is a important role is playing by your transport layer. So if anybody asks you what is the main difference between your internet layer and your transport layer, is transport layer is a local and your internet layer is a global, because which can able to transmit your data onto multiple persons and multiple data. So here what is going to happen when sender is here and receiver is here. So the first layer, the interface to the user is application layer, and here also interface to the user is application layer. And when we are using a transport layer, and here also transport layer, if you observe, the transport layer is a local to the mission. The transport layer is a local to the mission, it's not a global. And here also transport layer is a local to the mission, which can, why I am saying local, in the sense it cannot spread over onto your network. The spread over onto your network is only internet layer only. So this local mission is trying to communicate with your local application layer. Your local mission is trying to communicate with your local application layer, right? And this application layer is a high-end layer which is running a different types of protocols, high-end protocols. So dear friends, the transport layer is a local which is trying to communicate with application layer. But when you are talking about the internet layer, recently we completed IL also, internet layer, which is trying to see that your data can be spread over onto their network on multiple internet layers. But transport layer is not like that. As it is a local, doesn't mind about the medium. So directly it is interacting with the other particular transport layer only. That's why your transport layer is a what? End to end. It is a local to the mission and it is end to end. It doesn't involve in any kind of a medium which are there between your sender and your receiver. For example, I am taking that I have got a router between them, and transport layer do not mind about this because the transport layer is a end to end. So only it interact with from sender to the receiver, not to the any intermediate. That's why, my dear friends, you see that the importance of transport layer is like this. So I told you internet layer is a what? Global. Why it is a global? Because it can able to communicate with other kinds of networks. It can able to exchange your data packet among other networks. But transport layer is restricted to your particular system only. And now Another important point is, so the transport layer is located between network layer and application layer. So last session in the layered architecture, I explained about this. Your transport layer is a interface between, please understand, your transport layer is an interface between your downward layer, that is internet layer, and it is also interface to your upper layer, that is application layer. Now you see, so whatever application layer is sending, then transport layer receives and try to put it in understandable format to your internet layer. So transport layer provide the services to upper layer in the form of bytes. It's a very important question. Transport layer provide the data service to upper layer in the form of bytes and provide the service to lower layer in the form of what? Segments. So upper layer it is providing data in the form of bytes, and lower layer it is providing data in the form of segments. And transport layer provide two kinds of services. It offers connection oriented as well as it offers connectionless. So when I am talking, there is a transport layer and transport layer. In between we are having some router and some switch. But transport layer do not mind as it is end-to-end layer. So directly source is going to communicate with the receiver. Here when I am saying a source, it is nothing but a what? Your transport layer only. Destination is nothing but transport layer. Now what is going to happen? It do not know that there is a medium exist, because internet layer knows that there is a router exist, but transport layer do not know that there is a router exist because it is end to end. And I said that transport layer provide two kinds of services. One is a connection oriented in the form of TCP. One is a connectionless in the form of UDP. So both are there in your transport layer. It provides connection oriented services, nothing but a three-way handshake protocol we are using, and UDP is a completely what? Connectionless protocol. There is no connection requirement before exchanging of your data. So real-time example of your connection oriented is your HTTP protocol. Your HTTP protocol is one of the real-time example to your connection oriented. So whenever in the browser you type HTTP or HTTPS, first it start establishing a connection with your other end server, then it get the reply, then it start exchanging the data. So unless and until you try to establish the communication using a three-way handshake protocol, you cannot able to have a communication with the other particular node. Naturally, you people may prefer that where exactly the transport layer role. Yes, transport layer main role is between client and server architecture. So whenever internet become famous in the 1990 series, then lot of research and development is happened on the transport layer, because at that time whenever you talk about the internet, there are servers are there and there are clients are there. Now what will happen? So whenever client is to interact with your server, then there is a requirement of what? Either you establish the connection using a TCP or you transmit your data using UDP. So if I'm saying myself is Sameksha and I want to interact with the Unacademy YouTube channel, please understand, I want to do with Unacademy YouTube channel. So when you type this link, automatically what will happen? You're trying to establish a dedicated connection in the form of three-way handshake to your YouTube. Otherwise, if somebody want to access your Google, so I say that I want to access your Google. Now here what is going to happen? First I am typing http / your google.com. First, it will not directly open your page. Please understand. First of all, your request will go to the server and the server is going to give you the reply. Unless and until you get the reply, connection establishment reply, you are not going to see any kind of page. Sometime you also will see page expire error or page not found error, 404 error you are going to get because the domain is not exist. And I want to tell you one important point. This is one of your previous GATE question. I'm asking you, some node X would like to access web server. So I'm giving you 4 different steps. Step 1, establish TCP connection. You need to put it in a proper order. And the second step is search for a domain. So very important transport layer. We are learning advanced computer networks. So we already completed initial lectures, basic computer networks. So now we are in advanced computer networks. So we are learning transport layer. So you want further details, please refer Horizon textbook. So second step is search for a domain. And third step is HTTP request. And the fourth step is HTTP reply. So please put them in a proper order. This is your first question. So if a node would like to access any web server or any kind of server, whatever it may be, I have given you 4 steps. So please put them into proper order. For example, when you type something on the internet, first step is what? Is it establishing the connection? Or is it searching for the domain? Or first you are giving a request? What is correct? So can anybody? What is the first step? Will you establish the connection or will you search for the domain? So naturally we have regular habit to access any kind of servers or any kind of access. So what is the correct one? So now I am telling you which is the correct one. So sometimes that's why general knowledge is required to answer such kind of questions. So the first step is what? So you also can see by typing in the Google, first it is giving you a message at the taskbar that searching for the domain. If domain is not available, then it will give you that page not found. If domain is available, then what will happen? Your connection is going to be established. So this is the first step, and the connection establishment is the second step, and your request will go. This is your third step, and a reply will come. This is your fourth step. So this is the order you need to keep in order to access any kind of content from the web. So come to the points. What are the important points of your transport layer? So first one is the transport layer is an interface between your application layer and your internet layer. So the transport layer provides end-to-end byte stream over unreliable internet network, because internet network is not a reliable, it is unreliable, and it is a completely software based. It's PDU in the form of a segments. It provides services to upper layer in the form of bytes and to the lower layer in the form of a segments. Now you need to understand what is a byte, what is a segment. I told you your transport layer is an interface to your upper layer, that is application layer, and to your internet layer. I said it provides information in the form of bytes, and it giving information to lower layer in the form of what? Segments. That means this transport layer will exchange to other transport layer only in the form of what? Segments only. Please understand carefully. So what is a segment? We are all having a doubt what is a segment. Please understand. So what is a segment is, please understand carefully. Your application layer PDU, if you guess, please listen, application layer protocol data unit It is sending data in the form of meshes. Transport layer sending data in the form of what? I already said, segments. And internet layer deals the data, its PDU is packets. Please stay away all the transport layer lectures. In data link layer, your PDU is in the form of frame. And your physical layer, data in the form of its PDU is bits. So you're all having a doubt what is the meaning of segment. Now let me show you segments. For example, sender side application layer is sending data something like 1000 bytes. Next, when you look at the transport layer maximum capacity is 100 bytes. Now what will happen as your input is, please understand, as your input is greater than your maximum segment size, MSS. MSS stands for maximum segment size. Now I cannot send entire your 1000 bytes of data. Then there is a requirement of what? Splitting. That splitting is a what? Segmentation. Now listen how the segmentation is going to happen and how many segments you are going to get. You are giving me data that is 1000 bytes, but my maximum segment size is 100 bytes. So roughly I am getting 10 segments. So what are your segments and how they are being exchanged? So your 1000 bytes of data, I am giving a numbering because transport layer is going to provide a unique number to every one of your byte. Numbering always starts from 0 and it goes to 999 bytes. Right? So every of your maximum segment size, I am saying that it is 100 bytes. So first, client or server, whoever it may be, for example, client is uploading first segment. The segment is 100 bytes worth segment I am sending. This segment consists of numbering 0 byte dot dot to 99 bytes. And now every one of your segment is also be given number. So what is the number of this particular segment? Because transport layer can understand only in the form of segmentation only. Therefore, what will happen? Your segment number is your first byte number only. Therefore, your segment is identified with segment 0. This is your first segment. And now, the other party received your segment, that is a segment 0, which consists of your 0 byte to 99 bytes of data. Somehow, this 100 bytes of data is handed over to its upper layer. Now you got a free space, again 100 bytes here, assume. Now, the server has to give you acknowledgement. Acknowledgement is a mandatory, especially in transport layer, while you are using TCP, not in UDP. Now, acknowledgement is always come for +1 to your last byte you have received. The last byte you have received is the 99. So you will get a positive acknowledgement as S100. So one round trip time completed. Please understand. The transport layer looks into always round trip time only. The first round trip time completed. Now again, the guy is sending, as you are requesting for S100, then he is releasing S100. Can anybody guess what is the first byte number in this? S100 worth of 100 bytes. So what is the first byte number? Your segment sequence number is your first byte number only. Therefore, your first byte number in that group is 100th byte number and plus 100, which is nothing but 199. What will happen? This guy, other side received So 100th byte number to dot dot 199 byte number. These complete bytes are under the sealed with your segment number S100. Now this is one of your RTT. Now you got other side, so two segments are already went. So segment 0 we pushed, and the segment 100 you got the acknowledgement, and I am sending a segment 100. Now you got the acknowledgement for S200, so S200 is going. Then you got the acknowledgement for next segment. Then he is sending S300. Now you got the acknowledgement. So likewise, what will happen? The client releases to server how? First segment 0 dot 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 to last segment, that is S9. Can you guess? Can you guess how many bytes are there in your S900? Your S900 consists of 100 bytes of data. Do you know what are the numbers of your 100 bytes as 100%? Your starting number is your 900 byte and ending number is your 999 byte. So altogether we pushed 10 segments, right? There is a beautiful question on this. So I'm saying the one of the two responsibilities of your transport layer is a byte number and a segmentation. Now what is the question is asked in the last time? He said client pushed S0. So this is successfully received, which consists of 0th byte to 99 byte. So now he is giving a positive acknowledgement, that is S100. Now the client is releasing S100 to you. Unfortunately, this is lost. This is lost during data transmission. So now what is the other guy's reply? What is the server reply? The server is going to give you a negative acknowledgement. Do you know what is the negative acknowledgement of that? You will get negative acknowledgement only the expected one only. As I already received 0 byte to 99 byte, and I am expecting for next segment, that is nothing but 100. But I have not received any response, so I am giving negative acknowledgement, that is S100. It may be lost or it may be damaged, whatever it may be. Now the other guy has to send you once again S100. So now he will reply. If it is successfully arrived to him, now he will reply with next number S200, because this consists of 100 byte to 199 bytes. Now answer to my question. This is your one of your previous question on this. Sender send two segments back to back. Two segments back to back. One is S80, the other one is S95. First question, S80 is lost. He is asking how much amount of data is there? How much amount of data is in S80? Please answer. How much amount of data is in segment 80? Question mark. And my second question is, dash is the negative acknowledgement. What is the negative acknowledgement number? So please answer to this question. How much amount of data is there in S80? And what is the negative acknowledgement from other party? Please respond. What is the answer, my dear friends? how much amount of data, this is a success, this is a lost. So how much amount of data is there in SAT? Please respond. And what is the negative acknowledgement you are going to get? So we are going to get negative acknowledgement. So whatever is lost, that is only the number you are going to get as negative acknowledgement. That is SAT. And how much amount of data is there in SAT? You know, let us numbering here. What is the numbering? As I am sending 80th segment means your starting byte number is how much? In that segment, what is your starting byte number? In that segment, the starting byte number is how much? It is your segment number is your first byte number. And what is the ending number? Your ending number is nothing but what? As you are requesting for S95 in the sense, S95 you have sent means he has given acknowledgement for S95. Please understand. He has given acknowledgement for S95, which means that the previous byte is your last byte because acknowledgement always comes for the next expected byte only. Therefore, 80th byte is your starting number and before your next acknowledgement is 94. So 80 by 2, 94, how much amount of data is there in your SAT is, it is almost all 15 bytes, inclusive of 80 and inclusive of 94. So how much amount of data is in SAT means, it is how much? 15 bytes. So this is the second responsibility. Now let us see other responsibilities. So transport layer offers both connectionless as well as connection oriented services. So according to UDP, this is and according to UDP, this connectionless. So it provides services to application layer and application as network layer is going to provide the services to upper layer, that is a transport layer. Please understand. It provides services to application layer because lower layer has to provide the services to upper layer. Please understand. And the internet layer is going to provide the services to its upper layer, nothing but transport layer. Please see, internet layer provides services to transport layer provides services to application layer. Because we know what is the reason, lower layer has to provide services to upper layer, has to provide services to upper layer. Now let us see, this is what exactly the meaning of what? Segment. A segment consists of what? Please understand. A segment consists of your payload of your segment, and every segment is identified by header. The minimum header size according to TCP 20 byte and the maximum header size according to TCP is 60 bytes. Now this is inside. Now the packet has got sealed it. So the packet header is formed here. Now data link layer formed a header there and the data link layer header and trailer is going to be added. So you know this is in the form of encapsulation. Because your segment is a packet into a packet and your packet is formed into a what? A frame, and ultimately the data is in the form of what? Bits while you are releasing your data onto the medium. See that? Segment will be associated with a header and packet will be associated with a header that is a minimum 20 byte and a maximum 60 byte. And your frame header minimum 14 byte and a trailer 4 bytes. Hi Nishikumar. So what is the difference between your transport layer and network layer? So the difference between transport layer and network layer, as I already told you, transport layer resides in the local machine only, whereas your network layer spread across the network, because internet layer is only responsible to exchange the data over the network, but transport layer takes your packet and see that it is going to be handed over to application layer. So what are the main functionalities of transport layer? Number one, process to process communication. And next, it deals with the socket address. Either you talk about the TCP or you talk about the UDP, it deals with the socket address. And next, encapsulation and decapsulation, multiplexing and demultiplexing, pushing and pulling, flow control, buffers, error control, sequence numbers, acknowledgements. Now let us learn about each and every functionality. The main principle is, this is one of your previous gate question. The main principle of your transport layer is a what? Process to process communication only. Among all the principles, the main objective is process to process communication. So what is it? Listen. Now I want to explain like this. There is an application layer. Here also application layer. It is talking with the HTTP it wants to interact. It is also trying to interact with HTTP. Application layer can run with a multiple number of higher level protocols, not only HTTP. It may deal with HTTP, it may deal with FTP, whatever it may be. Now it is going to communicate with a transport layer. Now, transport layer, if you assume that I am using a TCP, and now finally, what is your process? You got a new process. What is it? HTTP combination with TCP. This is your new process. The same, so however it is happened at the one party, the same is supposed to be happened at other party. So what is the meaning of that? Whatever process you created with this kind of scenario, and the transport layer is also exactly supposed to hand it over to HTTP only. It should not be handed over to any other upper layer protocol, even though upper layer protocol supports multiple number of higher level protocols like HTTP, FTP, SMTP, DNS, and many other protocols are there. It should not be cross transmission. So the transport layer must exactly transmit your data to HTTP protocol with the help of your TCP only. So your sending process is this, and your receiving process is also supposed to be HTTP plus your TCP. So this is what is the meaning of process to process communication. Let us see what are the different steps. So network layer is responsible for communication host to host, and it can deliver the message only to the destination computer, but it is incomplete delivery. Why it is incomplete delivery? Because it cannot able to hand over to your correct process. So who is going to involve to handle your data to correct process? That is your transport layer. So its main functionality is a process to process communication. So a process is an application layer entity that use the services of transport layer, and the transport layer protocol is responsible for delivery of your message to appropriate process. That's why it is process to process communication. So this is an idea. So your internet layer is talking with different kinds of networks, and it hand over the data to here, but it is not hand over the data to the correct process. So you want to hand over the correct process, what is required? there is the requirement of your transport layer. So transport layer is only knows that to which of the upper layer protocol or upper layer process I need to hand over the data. There may be multiple number of processes, I don't mind, but I am going to exactly hand over data to your exact process. This is process to process communication. So what is addressing? So your transport layer is mainly for client server architecture. That means client requires some kind of a port number and server also requires some kind of a port number. And we are trying to build in the form of what? Socket address. So to establish a communication, we must define local host, local process, and remote host. So in order to deal this, there is a requirement of address, that is a socket address, which is in the form of what? Your IP address and your port number. Therefore, client TCP is also coming with that socket address. The socket address consists of, anybody, can you say what is your socket address size? Socket address size, how much? Socket address size, is it 32-bit or 64-bit or 128-bit? What is your socket address size? So your socket mainly consists of two parts. One part is port number and other part is your IP address. Other side server also has got same concept. So as I am using transport layer which deals with a socket address, here also we are having a same scenario. What is that? Your IP address and your port number. Can anybody say what is your socket address size? Your socket address size is a combination of these two. According to IPv4, so your IP address size is 32-bit and your port numbers are default size 16-bit. Therefore, your socket address size is 48-bit length. This is a standard and it is a fixed forever. So your port number capacity is a 16 bits and your IP address is a 32-bit. So altogether we are having your socket address as 48-bit length. Now we know IP address already we learned. Now we are trying to learn about your port number. So port numbers are three varieties. One is reserved to server side, one is reserved to client side, and one is a what? Which are registered with your IANA or ICANN. Now let us see what are the types of the port numbers are there. How many port numbers you are having? As I said that your port number how many bits? 16-bit capability. Therefore, I am having 2 power 16 port numbers. So what is a 2 power 16? Which is a 65,536 port numbers you are having. And this is categorized into three varieties. One is a purely server purpose and one is a client purpose and one is for what? A companies who can able to design network printers and all. So first one is registered and official and other one is ephemeral. Now let us see. So first variety category is 0 to 1023. You may ask me any protocol which you know that range is in between this range only. For example, you talk about HTTP, it is in the form of 80. You talk about file transfer protocol, it is in the form of 20 and 21. You talk about SMTP, it is a 25. You talk about any protocol, DNS or POP, whatever it may be. So it is going to be what? In this range only. So server side numbers are 0 to 1023 because it should be uniquely identified. It should not be redundant. And if you are looking other category, we are using for what? Client side. What are the client side numbering? It is a 49 151 152. Your next 65,535 because these port numbers are split from 0 to 65,535 only, numbering always from 0 and ends with n minus 1. And this middle group is very important, which consists of 1024 number to your 4951. So server side numbers are first group. This is your first group. And client side numbers are your last group. Now let us see them. So address means consist of IP address and port number. So port number plays very important role. Well-known port numbers, they are 0 to 1023, which are under the control of ICANN. And registered ports, which is 1024 to 49151. And they can be registered with ICANN to prevent what? Duplication. And the other variety is a dynamic ports, which are all 49152, 65535. And these ports we are assigning to client, and this port we are assigning to what? Server. So port numbers at a client side. The client program defines itself with a port number called ephemeral port number. Why? Ephemeral is nothing but what? Short-living. So short-lived port numbers. Soon after your data transmission is completed, then your connection is what? Disclosed. Therefore, there is no need of that port number. Again, client may come with a different port number to have a different task. That's why their living time is a what? Short-lived. And port numbers at server side. So you cannot randomly choose in them. For example, you say, some people will say that, can I go for HTTP something like 70? No, it is a standard protocol. You cannot choose a port number randomly for what I mean to say registered sites, registered protocols. So HTTP should not be randomly selected. It should be always what? 80 only. Because they are long-lived port numbers. Please understand, they should not be randomly available. They should be what? A fixed and dedicated. Why? The process at the client side wants to access the server and use its services will not know the port number. That's why your universal port number is known as what? Well-known port numbers. Because you cannot assign port numbers randomly. So socket address, I already told you, every particular computer, especially who are dealing with your transport layer, whoever is dealing with the transport layer, they must deal with a what? Socket. Establishment of the socket is a very, very important. So they deal with either TCP sockets or UDP sockets because both are belongs to your transport layer only. So your socket address is a combination of IP address and port number. As I told you, your IP address is a 32-bit and your port number is a 16-bit. So your socket address is the length of your 48-bit. So client socket address defines the client process uniquely. Server socket address defines server process uniquely. So this is the concept. IP address and your port number together is a what? Your socket address. Now the transport layer at the client side is trying to pass this port number in order to establish the connection with the what? Server. Then server understand that this is the client socket. I need to accept the connection and I am going to give you the reply. Please remember the server side socket address is different. Please understand. The server side socket address is different. Why? Because please understand the port number may be the same, but your IP address is going to be the different because the client is coming with some other IP address and the server may coming with the different kinds of IP addresses. It may be the different because your socket address must be unique at the client side and unique at the server side. And the next one is encapsulation and decapsulation. So what is the meaning of encapsulation and decapsulation? Encapsulation is adding of headers. So we know what is the meaning of that. Whenever application layer sends a message, and this message the transport layer takes and add its header. So that's why up to here we are calling it as a what? Encapsulation. Decapsulation is happened at the other side. It is nothing but a what? A removing headers. So you have received your TH and your transport layer PDU. This is your PDU or payload. And now we will remove this header and hand over to your application layer. So encapsulation is happened at sender side, decapsulation is at receiver side. So adding of your transport layer header is encapsulation, and removal of your header at the transport layer is a what? Decapsulation. So your application layer at the receiver side will receive only after elimination of what? Your transport header. So this is an idea. So we are attaching a header here and we are detaching a header here. And next one is multiplexing and demultiplexing. So what is the meaning of this? Please understand. So here is the sender side application layer. So this application layer wants to establish HTTP data transmission. I can do multitasking because your operating system supports multitasking. So I want to upload the file, and the other one is that in another browser I want to do mailing SMTP. Please understand. At a time, the application layer at the sender opened the three browsers and wants to access some HTTP protocol. That means accessing some information from website, and FTP. Either you are downloading movie or audios and uploading video or audio. FTP protocol is for uploading and downloading, and SMTP protocol for what? Transmission of your mail. But you observe one beautiful point here. First, the request will come to the transport layer only. But transport layer has got only two varieties of protocols. Either I can work with you TCP or I can work with you UDP. No other protocols are there with me. But recent R&D SCTP is also there. But let us concentrate TCP and UDP. But you observe the nature of HTTP is TCP. It should establish the connection, three-way handshake protocol. FTP is also based on TCP. SMTP is also based on TCP. Therefore, what will happen, my dear friends? TCP is only one, but it wants to act with the three different upper layer protocols. It's highly impossible. Now, the beauty of your transport layer is a what? It is having the concept of what? MUX. Logical muxing I am doing. What is a logical muxing? I am trying to give you three kinds of connectivity. One, okay, no problem, you can come randomly. So HTTP plus TCP, one particular local process, and FTP with your TCP, another particular local process, and SMTP with your TCP is another local process. Now I combine them and push it to the internet layer. Now other side, we want to do what? A demux. What is a demux? This is a mux. And demux means at the other side transport layer is responsible to hand over the exact processes only. Therefore, what will happen? Here is the receiver. He is waiting for three varieties of the process. One, I want to push it to HTTP. The other one, I want to push it to FTP. The other one, I want to push it to SMTP. So the transport layer is a very intelligent. What it is going to do? It only one TCP is there. Now it is trying to split into one HTTP process and one FTP process and one SMTP process. So here we are doing a concept of what? demux. So that is the concept of what muxing and demuxing. One of the role of with your TCP, you can do either with the TCP with the multiple upper layer protocols, or you can do, there are some standard protocols who follow UDP also, like your TFTP, DNS, SNMP, some of the protocols who follow UDP. So your upper layer protocols, whatever protocols you give, I don't mind. I'm going to do what? Process to process communication, mux them, make a single unit, distribute here and send them to your required other processors. This is a muxing and demuxing. So whenever an entity accepts from more than one source, it is referred as a what? Multiplexing, and deliver items to more than one source, it is referred as a what? Demultiplexing. So the transport layer is responsible to perform mux and demultiplexing. So this is the concept. Listen carefully. So application layer is sending three processes, as I already explained. Process 1, process 2, process 3. But only one transport layer only one TCP only. Then what it is going to do? It takes all the process, merge them and send them. But distribution is a very clever. What is that? So the corresponding processes will go to exactly other side and other process will go to other side. That means it is trying to hand it over to two process to one server and other process to other particular server. This can happen in your transport layer. And other one is pushing and pulling. So these are all the basics for us to learn next consecutive lectures of transport layer, because we will learn three-way handshake protocol and congestion control, flow control, silly window syndrome, and persistent timers, keep alive timers. To learn advanced topics in transport layer, learn the basics well. That's pushing or pulling. This is one of the concept to implement TCP flow control. There is a relevant. So every one of your transport layer function is relevant to one of your subtopic in your GATE examination syllabus. So what is a pushing and pulling? Pushing means without request of the receiver, I am pushing the data. That's meaning of pushing. So sender keep on pushing the data. 1, segment 0, and segment 100, and segment 200, and segment 300 continuously is sending segments. There is no reply from other party. Without requesting, I am delivering the goods. That's the meaning of what? Pushing. Because of this, you are having a concept of what? Congestion. Because we don't know what is the capacity and what is the situation at the receiver side transport layer, but simply I am sending the data segments to other party. Somewhere else you will feel the congestion, then your segments are going to be discarded. So that's why if you are not having concept of flow control, then there is a what? Congestion. Now what the pulling is saying, you don't send the data, I will give you a requirement so that you will send the data. So this is the pushing. So what is the pulling? For every transmission, other party will give you reply. Segment 0, yes, I need segment 100. Segment 100, yes, you send me next segment 200. So when you are asking like this is what is the meaning of what? Acknowledgement system based is a concept of pulling. So pulling never leads a concept of a congestion, because it's a perfectly implemented flow control. Flow control is a perfectly implemented in pulling, but in pushing, no flow control, which leads to a concept of a what? Congestion. This is about pushing and pulling. See this? Pushing means what? We keep on transmit the data. Pulling is nothing but what? We request first, then send your data. Yeah, come to the point of flow control. TCP uses flow control technique. That means transport layer uses flow control techniques such that the sender cannot swamp the receiver. We want to provide a mechanism such that there should be a proper synchronization between transport layer of sender and transport layer of your receiver. Therefore, what the flow control is saying, two important things. The data which is produced faster than, if the items are produced faster than they consumed, then the consumer is going to get a concept of what? Congestion. And therefore, some of the items are going to be discarded. I cannot digest. This is a lack of flow control. Now, second point is, if the item produced by slower than they can be consumed, then the consumer is going to what? Wait. The system efficiency is going to be down. Sender is a what? Slow sender, but receiver is a very fast receiver. This is what is the point. So slow sender and a fast receiver. Second point. And the first point is a what? Same story. What is that? Fast sender opposite and a slow receiver. So in the first concept, you're having a what? Congestion. But in second concept, there is no congestion, but the efficiency of your channel is going to be down. So in order to implement the flow control, what the sender is going to do and what the receiver is going to do, we will learn in a separate topic called TCP flow control. But as a time being, I am sending. Sender is maintaining a congestion window known as a CWND. Receiver is maintaining a receiver window known as advertise window. What is the rule to implement a proper flow control? To implement a proper flow control, the rule is one of your previous gate question. What is that? Sender must send only minimum of CWND, AW. Please remember, either it may be a fast sender or a slow sender, I don't mind. According to this rule, I am going to follow. What is that? Minimum of sender window, receiver window. So that's it. This problem हो जाएगा, cancel हो जाएगा. This problem cancel हो जाएगा because we are following a what? Minimum. So that we will learn in depth in TCP flow control as one of my next lectures. And the last one is a what? Buffering. So transport layer following a concept of what? Buffer. What is the meaning of buffer? Let me explain like this. So sender side application layer, receiver side application layer. Both can communicate using the protocols, but data transmission is done vertically. Please don't forget that basic information. First, the data will come to the transport layer only. Now, what I am doing here, transport layer maintains some buffer than your capacity. For example, my capacity is something like 100 bytes. So when you are transmitting this 100 byte of segment to other party, so other party maintains some buffers. Okay, I have received 100 bytes and I'm also going to maintain some buffer. Buffer means what? If at all you transmit more to me, I need to sustain up to some level. That is a danger zone in your congestion. So up to some level I can able to maintain. That I am going to keep it in a what? Buffer only. Now let us see. First I have transmitted segment 0 with 100 byte of data. Okay, no problem. A receiver is receiving your segment 0 which consists of 100 byte of your data. Now again immediately the sender is sending one more segment with 100 byte, that is segment 100. Then I have got the capacity, so that I am going to keep it in what? Buffer only. So segment 0 is here and segment 100 is here. The application layer is a very clever because it takes the services of your transport layer such that first segment 0 will be consumed, then after that segment 100 is going to be consumed. So it is not going to consume in order data, they are going to consume only ordered data only. That's why there is an importance with a what? Buffers. So what is the meaning of buffer? So flow control can be implemented using buffers concept. One at the sending transport layer, other is at the receiver transport layer. So what is the idea? When the buffer of the sending transport layer is full, it informs the application layer that stop passing the data to me. So immediately application layer at the sender side, by receiving this alert, immediately has to stop it. And receiver side, so when there are some slots are there, it informs the application layer can pass the message. This is at sender side. Receiver side also, this is at receiver side. When the buffers of receiving transport layer is full, it informs the sending transport layer stop it, stop sending the data. When there are some vacancies are there, then we will inform to the sender transport layer, please send me. This is at the receiver side. So sender transport layer and receiver transport layer, how they are communicating. So if you are having capacity, okay, ask him to send. Otherwise, we will tell him to stop it. Stop sending. Therefore, the sender transport layer immediately stop because your buffer is what? Completely filled. And error control. So error control is one of the responsibility of your transport layer. So error control is nothing but detection of corrupted packets or detection of failure of your data or detection of loss of acknowledgement. Such kind of things comes under into error control. What is that? First one, segment lost. Second one, segment corrupted. Third one, acknowledgement lost. And fourth one, acknowledgement delayed. So keep track of lost or discarded segments and resend them, identifying duplicate packets and discarding them. So out of order packets, you need to keep it in buffer. So how can you do this buffer? How can you do this error control? This error control can be done using a what? Sequence numbers. So sequence numbers is a very important role it's playing in the transport layer. So error control requires that the sending transport layer knows that which packet is to be resent. And the receiving transport layer knows that which packet is going to be the duplicated so that I can able to see the discard and which packets are going to out of order. This is all because of what? Sequence numbers only. That's why every particular segment is supposed to what? Given a number. And these numbers can be what? Reusable according to your window protocols. For example, you see client transmitted S0 to other party and again he is transmitting S0. Now server side can able to detect that is the second one is a duplicate. How he can able to detect that this is a duplicate? Because already I am comparing S0 and again you are receiving S0. So I can understand that this is a duplicate. So numbering is a very much resend the segment with the sequence number. And receiving transport layer also can able to detect duplicate segments if two received one are having same sequence numbers. So your limit is also very much important. How much I can able to keep your limit is, as TCP, as your TCP, one of your protocol of your transport layer is following go back n, and so I am following a what? 2 power n minus 1 range. Don't forget, this is a very important question. As TCP is following what? Go back n, and some of the principles of selective repeat is the combination of selective repeat and go back n protocol. Therefore, it's maintaining 2 power n minus 1 sequence numbers. So this is how you can able to set the sequence number, and that you can also use a wrap around reusing of the numbers. For example, I say let my 2-bit sequence number I am using. So what is the meaning of total sequence numbers here? Please recollect data link layer. Your total sequence numbers are 2 power 2, which is nothing but a 4. So the transport layer at other end 1 0 1 2 3. Then after that you can reuse them, wrap around 0 1 2 3. After that you can reuse, that is 0 1 2 3. This is the concept. That means that we can wrap around the sequence number so that sequence number can be reused. For example, I am using 0 to 15 one set. Again I can reuse 0 dot dot to 15. That means I am using a what? 4-bit sequence number. So 2 power 4 is nothing but a 16. There you are going to get 0th number to 15. According to that, your n value is 4-bit, which is nothing but 2 power 4 sequence numbers you are going to get it. So last functionality of your transport layer is acknowledgement system, compulsory acknowledgement system. So we are having a positive and negative acknowledgements. So positive is for +1. Please understand. Positive acknowledgement is always +1 to last byte received. Last byte received. And negative acknowledgement means what? What? Same segment number. Same segment number which is a lost or which is a damaged. The receiver side can acknowledge acknowledgement. So corrupted packets, the receiver is going to discard. The sender can detect loss of packets by using a what? Timers. So out of order segments can be either discarded or can be stored until missing one arrives. So duplicate segments or data is going to be discarded silently by the receiver. So if acknowledgement has not come within the timer, then sender is going to resend the segment. So that's it, my dear friends. These are the main functionalities of your transport layer, what we learned in the duration. Now, in the next lesson, we are going to learn about TCP segment header. Very important, don't miss. We are going to learn TCP segment header. That is our next class in the YouTube series lectures. So this is my 50th lecture. Those who missed my previous lectures, please follow previous my lecture, then you will understand lecture by lecture. Start from lecture 1 so that you will understand better. So stay tuned to Unacademy and stay tuned to my classes. Thank you for all your support. Thank you very much.